Hello guys, and welcome in this new session. Today I want to try something new. I'm going to try to build an example of the PBR processing from scratches using the NervLand project. So yeah, we're just going to do that together, and I basically have no idea yet how long this will take and if there will be problem in the way or not. So we'll see if we can put everything for this in a single recording or if I need to get that into multiple pieces. Hopefully it should go pretty fast. We'll see. So the idea I have is to use one of those models that you can find on this repository. So GLTF simple models version 2.0. In fact, I don't even know which version I am compatible with, so we'll see if this is breaking anything. And one of the models that I really like is this one, the DamagedHelmet. So let's try to prepare a sample for that. To work with it, with this, we'll need to download the file, of course. Let me just check what are those checkboxes. Okay, normal map, occlusion, emissive map. Emissive map. That's interesting already. So let's see what we have in there. We have different versions. The first one is a binary version. Not even sure I am compatible with that, so we probably need to check that, but later. Then we have GLTF embedded with the image directly embedded into the GLTF file, I guess. Yes, we could try this one, but to start with, yes, I prefer this version where all the images are external, so we can just load them manually. So we'll start with that, and maybe if we have time or in another recording, we'll try the other versions. So let me download that and prepare a minimal sample first. So I have created a new example file, which I call DamagedHelmet in this case, and this one is currently just a copy of what we have built in the latest example that I made, which is a simple scene here, because in this simple scene all we're going to do in fact is to use a scene manager to create a scene, and in there we're going to add the skybox and a PBR rendering process for a given object. Currently the object that is selected here is a Cerberus gun, so I didn't change anything, just made a copy of this file into this one. After that we need to add the changes in the CMake file here to actually build this project, this example. And also I am adding another script here in the MVP configuration to be able to run that easily with a simple command line. So I've already built everything, and now we can just execute this one, and this is currently just going to display the Cerberus model, as I said. So next step would be to change the model that we're displaying here. And yes, in fact I've just downloaded that also. Yes, we can show the files in there. In the models folder, test subfolder, I've added this DamagedHelmet binary and GFTL file. So those are the files that we have available here, and all the images. The thing which is a bit inconvenient currently on my side is that I need to place them in another folder to be able to find them automatically. So it's a textures folder in the test subfolder here, and so I have created this DamagedHelmet subfolder again, and we have those images located in there. And actually we can also access those files from here. So we have the models file added here and the textures added file here, which I should probably ignore on my repository for now. Let's do that. Okay, so now I'm getting ready to replace the Cerberus model with the DamagedHelmet model. But the first thing I'm noticing is if you check the textures that we have for damage model, we actually have here a metal roughness texture, and this one visibly you have two different channels in use here, the green channel and the blue channel. To me, it seems like the green channel would be the roughness, and the blue channel would be the metalness. So this is a problem with the pipeline that we have previously implemented, where we were using separated textures for the metallic part and the roughness part, because now we have those two combined together. So I need to figure out a way of how to provide the same texture and use the two different channels to access this data. Let's try to think about that. Okay, so the first idea I have here is to just assign the model file and the texture, and here you see I'm assigning twice the same texture for the roughness and the metallic part. When doing so, it's actually going to load the texture, create the texture only once, and then you're going to use the same texture for those two bindings. And then eventually we're going to reach this shader here to do the PBR processing. And initially we were using those two lines. So when you are provided with a metallic and roughness texture, you would use X, so the first channel in those texture to get the corresponding value. Now what I'm going to try is to use the same syntax, but in case I want to reduce the metallic part, then I'm going to check the third channel, so the blue channel, and for the roughness part we're going to check the green channel, so this is channel number 2. And in theory this could work. Of course this is breaking the previous implementation for the serverless model, so we need to find a way to deal with those considerations in a more flexible way, not just commenting content like that in the shader. So we'll get to this later if it's working, but now let's just try to rebuild that and give it a try to see if it's working. Okay, I just rebuilt my example and I am about to run it, but in fact I kind of like to understand what I'm going to run before I do it. And in this case, for instance, I know that I'm going to load the DamagedHelmet GLTF file, and what I can do even before I try to run anything is to try to compare the content that we have in the serverless model and what we have in the DamagedHelmet model. So if we go in this one, you will see that when it comes to defining the mesh itself, the mesh has 4 different attributes. So we have the position, the normal, the tangent, and the text code 0. And also this is an indexed mesh, so you have the indices buffer provided along the mesh itself. If you go now in the DamagedHelmet file, we need to figure out, in the mesh, what do we have? You see that you have this primitive here, but this time you only have the normal, the position, the texture code 0. We don't have the tangent attribute. And again, it's still in indexed mesh, so that's okay. But the fact that we don't have the tangent attribute is a problem for us, because in the shader here, we are actually using the tangent to build the real normal from the interpolation of the normal data that you get from the vertex shader. So yeah, we need to deal with that, because the format that we'll get for the vertex buffer will be incorrect. I'm not quite sure if it's going to fail. I mean, it's probably going to fail, because draw PBR here is going to set up everything with an appropriate vertex format. Okay, and the vertex format, this is provided as information, I guess. Okay, and for the information, vertex format is by default the position, normal, tangent, and text code 0. So it's expecting the tangent here. We could change that to not provide the tangent, but that's going to be no good and the shader itself will fail. How would you do it? That would be here, where you could provide, for instance, like this is going to be, what is the structure I use? STDV format, okay. If we remove the T, so this format here is the same without the tangent information. Let's just try that. It's going to fail. Okay, I just tried to run it and it's failing, but not really because of the change of the vertex format here. This file is not found. Oh, it's JPEG. Yes. Trying again. Another error again now because of what I was using for the name of the file. It's incorrect. The correct naming is this one. So fixing this. Okay, interesting. Now I'm actually just trying to load this file and I have an issue when it comes to loading some of the samplers that are defined in the file because the filter mode that is provided here is not supported, which is strange. I need to investigate this further and figure out what this value really is. Let me do that. Alright, so investigating this sampler issue that I mentioned just before, I can now see that in the DamagedHelmet file we have this entry for the samplers. So it seems that the idea is really to build a kind of default sampler in this case, and then, well, when I get to create a sampler, the issue comes from this call here, and this method itself, this is called when I'm iterating on the GLTF samplers on the list, and it seems that the value that we have for the min filter and mag filter are wrong. And in fact, then I try to dive a bit deeper into the GLTF library itself, which thankfully is only a header. It's a header only library. So we'll see that we have this function, which I believe is the main one will be used that will be used to create a sampler from the JSON data. And you start from an out sampler, and you here apparently set some default value for the wrap S and wrap T, but not for the mag filter or min filters. So you really expect to have them, maybe, and it's not the case here. We have only default values, so probably we need to add some default in there. I'll try that and I'll see how this is going. But first I need to figure out exactly where this function is called. Maybe this is already partially initialized before reaching this location. So maybe it's this little theory doesn't apply really. I need to check that further. But conclusion to that is I'm definitely not going to be able to display this damage model in this session. We have to fix this issue just to get the GLTF model to load. Maybe there will be other issues like that. Maybe it's because GLTF library is not fully compatible with those additional new standards in version 2 of GLTF. And once this is done, I also need to provide a mechanism to generate the tangent space, because we don't have the tangent attribute in this model, and we definitely need that for the PBR rendering to use the normal map properly. So failure, yep. I mean failure. We've done a few things already, and we're going to make it, but there are additional intermediate steps to cover, and I don't want to cover all this in this supposedly quick recording. So we'll get back to this another time when we have all the materials necessary to move forward with this task. So thanks for watching. See you another time. Bye bye.